Hello everybody, this is BBoss1997 and welcome back to my channel. In this video today I wanted to show you this homemade capacitor, how I built it, materials I used, and how you can make one yourself. It is a cool device that you can use for a couple different things. Most people would call it a Leyden jar, but all Leyden jars are capacitors, but not all capacitors are Leyden jars. And plus, this thing can be used with current electricity as well. So, let's get started. Okay, well this is a relatively simple device. All I used for it was a peanut butter jar, one of the more stout ones. I used some of this aluminum tape. What this is it is just aluminum with an adhesive on the back. This is paper to peel off when you're ready to use it, and it sticks to pretty much anything. It's very nice stuff for electrical work if you want to have like a track conductor of any kind. One layer of that goes on the outside, and this is a slightly trickier part, and another layer goes on the inside. You don't need all of this extraneous stuff. All you would really need is a bolt and a wire on the inside. I decided to use a copper strip because I had some of it laying around. You don't need this strip on the outside. You can just glue a wire, but I thought this would be just nice to have this little tab you can connect anything to. You don't need this insulator. I just put it on there to make it look cool, and you don't need this ball. The tip of a nut would look really nice. But I used this electrode from a Wimshurst generator that broke down, because I thought it would look cool. So, but I mean, that's really basically it. If you wanted to use it as a Leyden jar, how it would work is you would take like a styrofoam block, rub it on the carpet, and hold it near this a couple times, and what would happen is the electrons would go into here and build up on the inside layer. The plastic in between these two layers acts as the dielectric, and all the electrons build up on the inside, but they don't have anywhere to go. So therefore, because of the electrons in here, this is charged as negative, and this is positive because there's less electrons out here. And once you bridge this gap, a little spark will jump. So that's basically how a capacitor works in any case. But with current electricity, this inside part would become the positive, because that would be where the electrons are going to come out. So let's run some tests on this and show you sort of what it does. Before we begin, I thought I'd show you what the arcs from this power supply, which is what we're going to use to test this capacitor, look like when it's unhindered. So sort of nice little arcs we got there. And that's when those arcs come when it's just coming from the power supply with no kind of resistor or any capacitor attached to it. Now let's see how the capacitor changes this flow of electrons. Now this is where these tab connectors come in handy, because without it, without this one up here, I would have to wrap this wire around it. Now I don't want to strip it that far, because I'm only going to use it for this purpose once. And down here I wouldn't have a ledge to put this conductor plate on, so I just thought I'd mention that on a side note. Let's run a little test on this. Okay, well let's apply power to this. Power's on in 3, 2, 1. Now you can probably hear the hissing sound that the capacitor is making. That's because there are a little bit of corona discharges trying to go through the dielectric, but it's not working, because after all, plastic is an insulator. But that's not going to stop them from trying. The only way we're going to be able to get electrons to their respective sides is through a jumper cable, which is what I have here. So let's try this out. Now, I'm sure you can hear the difference. The other spark sounded sort of smooth. This one sounds very snappy. That's because That's because the capacitor is being charged on opposite ends at a rate of 60 cycles per second. We're using AC, we're going to use DC a little bit later, but it's being charged at a rate of 60 cycles per second. And it's discharging in opposite directions at a rate of 60 cycles per second. But the reason it's so snappy is because it is charging in spikes rather than in a sine wave, which is how normal electricity flows. So this waveform would have a more jagged form if we were to connect an oscilloscope to this. So let's do that again. I'm going to zoom in a little bit for you. It's probably not making my camera's sound system happy. I also thought I'd mention that if you are going to use this capacitor in this way, be warned that when you open this, because of all the corona discharges inside, there's going to be quite a bit of ozone that's built up, so you may want to be careful with that. I'm not going to use this capacitor for much of that, but if you wanted to build like a homemade bug zapper, use this, because as you notice, if you have ever seen the capacitor discharge from a bug zapper capacitor, normally the capacitor inside the bug zapper would make this kind of spark. You'll notice it looks very similar. So if you want to make a homemade bug zapper, you build one of these and hook it up in parallel with the grid, and you'll get a similar result. Now, let's try this with DC. Okay, so now I have my high voltage rectifier diode, which is located behind the capacitor, hooked up with the positive leg going to this ball, because I want this this ball to be the positive end of the capacitor. So I'm going to turn the power on in 3, 2, 1. You'll notice it's not as noisy. Let's do a spark. See what it looks like. It looks relatively the same. Now, I'm going to zoom in, and let's look at it when I turn the power off. See, there's still a little bit of a discharge. I don't know if you saw that on the camera. Let me do it a couple more times. See here, it's working more closely to a conventional capacitor. The reason the spark isn't very big is because it doesn't have a very large capacitance. Normally a capacitor, like an electrolytic, stores a lot of power because the foil is much larger and rolled up into a tight space, so there's more surface area for the electrons to collect on. This one only has one loop of conductor, and that's why the spark isn't very big. But see, I mean, that's what it looks like when you apply DC to this, with this being the positive leg. Electrons are building up on the inside, and they want to get to the outside to equalize the potential difference, aka voltage. So, I mean, there you go. There's a simple capacitor. You can make yourself. I wouldn't necessarily recommend trying this yourself, but just be careful if you do. As always, if you're working with capacitors like this, make sure that you discharge them and leave them discharged. Because this capacitor has such a low capacitance, you don't really have to worry about that, but you probably should if you're working with capacitors like older microwave oven transformers that don't have a bleed resistor on the inside. Okay, well, thank you for watching my little video on this homemade capacitor, and I hope to see you in the next video. Have a great day, and I'll see you soon.